Hi folks, we're going to do a radiation example problem, and here goes. If a person was on an episode of the TV show Naked and Afraid, at what rate would he or she radiate heat to the environment? Human skin has an emissivity of about 0.70. If this person's skin had a surface area of 1.5 meters squared, and their external skin temperature was 34 Celsius, and the air temperature was 20 Celsius. Now, since this is all about infrared radiation, we're going to use Stefan's law, which is power or change in energy over change in time is going to be equal to sigma, area, emissivity, and then the one temperature, the hotter temperature, minus the cooler temperature, and each of these is to the fourth power before you do the subtraction. What do we know from our problem? Well, we know the area is 1.5 meters squared. We know emissivity is equal to 0.70. We know Stefan Boltzmann's constant is 5.67 times 10 to the negative 8 watts meters squared Kelvin to the fourth power. Stefan Boltzmann's constant is on the back of that physics constant sheet I gave you, so you have that. The two temperatures that you have, one is 34 degrees Celsius and the other one is in 20 degrees Celsius. Now, each one of these temperatures must be in Kelvin to do this problem. So to convert to Kelvin, we're going to add 273 to each. So 20 plus 273 is 293 kelvins. 34 plus 273 is going to be 307 kelvins. And I think we have all of our information gathered. Now we can plug all of this into our radiation equation. So here goes. So the power, the rate of which heat's going to be dissipated, is going to be that Stefan Boltzmann constant, which is going to be 5.67 times 10 to the negative 8 watts meters squared Kelvin to the fourth power times our surface area, 1.5 meters squared, times 0.7 times 307 kelvins to the fourth power minus 293 kelvins to the fourth power. Okay, now what I'm going to do is I'm going to multiply all of this stuff together to kind of simplify it, and all of that together gives me 5.95 times 10 to the negative 8. This meter squared cancels. I'm going to end up with watts over Kelvin to the fourth power. Now, 307 to the fourth power minus 293 to the fourth power. I'm going to let you do that on your calculator, because if I write all those numbers down, it's kind of messy. It's just messy. Thank goodness for calculators. But when I do that subtraction, I end up with 1.513 times 10 to the ninth Kelvin to the fourth. Now the Kelvin to the fourth will cancel Kelvins to the fourth, and when I do the math, I end up with right around 90 watts. So that is about, this person is going to be giving off about the same amount of heat as a 90-watt light bulb. That means it's fun to cuddle other humans. All right, we'll have a more later, and I hope you have a fabulous day. See you then.